Recall that when we talked about the solutions of systems, we also had redundant, which led to cases of infinite solutions, and inconsistent, which led to zero solutions. Both of these lead to special cases of row-reduced echelon forms. Reducing an inconsistent system might result in something that looks like the following. If we use technology to row-reduce a matrix and received this matrix as our final answer, if we tried to interpret it as a system, it would tell us that x equals 2, 0 equals 3, and z equals 4. However, 0 does not equal 3. This statement is not true. This tells us that what we're looking at is an inconsistent system. In a redundant system, reducing might give us a row of zeros. Plugging a matrix and performing Gauss-Jordan elimination on a redundant system might have as an output a matrix of the following form. If we were to try to interpret this back as a system, we'd get that x plus 2z equals 3, and that y equals 2, and that 0 equals 0. Here, 0 equals 0 is true, but it's also redundant. To describe the infinite solutions of the system, first we know one thing for certain, y equals 2. To fill in the rest, let's start all the way to the right. The right corresponds normally, in this case, to z. We don't know what z is as a number, but we do know something about z. We know that x plus 2z equals 3, which means if we solve for z, we would get that z equals 3 minus x all divided by 2. Since this answer includes x, all we can put for x is just x. Our solutions are dependent upon x. As another example of a redundant system, and again we know that it's redundant if we translate as a system, we get x plus z equals 3, y plus z equals 2, and 0 equals 0. Again, this 0 equals 0 tells us the system is redundant. To describe the infinite solutions of our system, let's start by trying to describe z in terms of x. We can find that z equals 3 minus x. Here, we don't definitively know what y is. We can describe y in terms of z, and since we know z in terms of x, we can describe y in terms of x. And here, since we have x used in our answer, x will just be x.